Welcome to my video on electromagnetic waves for turning points, which is an optional unit in AQA A-level physics. Today we're going to be going over Maxwell's equations, we're going to be going over electromagnetic waves, and we're going to be going over the idea of light as an electromagnetic wave. Now, don't forget that if you want more information on this topic or you want a better diagram of an EM wave, to check out my resources on the My EdSpace website. And if you fancy joining in the fun with live lessons, check out the link in the description of this video. So let's get started. Now today we're going back to the 1800s to a chap called James Clerk Maxwell. He came up with these four equations known as Maxwell's equations. You don't need to know them, but I think they're interesting to look at because actually you guys already know this one. This one here is actually Faraday's law, just written in a different way. Now these four equations explain how electric and magnetic fields behave. From these equations, Maxwell hypothesized that there must be an existence of a wave which moves through both the electric fields and magnetic fields. He called it an electromagnetic wave because it moves through the electric fields and magnetic fields. Just like how we say that like a sound wave moves through air particles, an electromagnetic wave moves through the electric and the magnetic fields. And this is what James Clerk Maxwell thought that the wave should look like. He said that the oscillations of the wave should be at 90 degrees to the direction of the wave travel. So in other words, it should be a transverse wave. This is something we already know. So it's a transverse wave. But furthermore than that, Maxwell suggested that the magnetic fields and the electric field actually oscillate at an angle of 90 degrees to each other. Now, sometimes we abbreviate the magnetic field just to be the B field and the electric field just to be the E field. So the B and E fields oscillate at 90 degrees to one another. And the final thing that we need to know about these electromagnetic waves is that the electric and the magnetic fields are in phase. So when the magnetic field is at a maximum, the electric field will be at a maximum. When the magnetic field is at a minimum, the electric field will be at a minimum. So the B and E fields are in phase. Okie doke. Right. Using these equations and combining them, Maxwell came up with an idea that there's like a set speed that these waves should travel at. And it was given by this equation up here. C, which is the speed of the electromagnetic wave, speed of the EM wave, depended on these two constants here. Mu naught being the permeability of free space, and epsilon naught being the permittivity of free space. Now you've met this guy before, you met him when you were doing capacitors. So this is all to do with charged particles and electric fields. And this constant here, the permeability of free space, is all to do with how much magnetic field a current produces. So this one here is all to do with magnetic fields. Now, note please, because this is going to be important for a later video, that the speed of an electromagnetic wave depends on two constants. It doesn't depend on a variable, it depends on two things that are constant. Now, mu naught and epsilon naught could both be determined experimentally. Mu naught was found to be 4 pi times 10 to the minus 7 newtons per ampere squared, and epsilon naught was found to be 8.8542 times 10 to the minus 12 farads per meter. Combining these guys together in this equation gave the speed of light to be 2.9979 times 10 to the 8 meters per second. Now I say the speed of light because recently it had been discovered that by Fizeau that the speed of light experimentally was roughly similar to this number. So the discovery of this number from Maxwell's equations and the experimental measuring of the speed of light to be the same by Fizeau, who is a French physicist, meant that we could determine that light was one of these predicted electromagnetic waves. So light is an electromagnetic wave. Now, I hope you found this video useful. Don't forget, if you want more information on this topic or you want to see a slightly better diagram of this guy over here, to check out my resources on the My EdSpace website. Don't forget, if you like this video, to subscribe to my channel and check out the link in the description if you want to come and join my live lessons. Thank you so much, and I'm going to see you in the next video. Take care.